So in section 7.3, we're going to be working on adding together rational expressions. Basically, that's a glorified version of saying we're going to add together fractions. Some of these fractions can have things in the numerator like polynomials, etc. But basically, in order to add fractions together, we need things that have common denominators. If you have common denominators, then you can add their numerators and divide by that common denominator. So, for instance, in doing something like this, 1/6 plus 2/9, there's a couple things you're going to need to do. First of all, you're going to need to figure out what the common denominator is. So, one way to do that is this way. List all the different multiples of your common denominator. So, 1 times 6 is 6, 2 times 6 is 12, 18, 24, 30, 36, etc. The multiples of 9 would include 18, 27, 36, etc. But what we're looking for is the lowest common denominator. Now, it's true that 36 is a common multiple of each of these, but the lowest common multiple, and what's going to be our lowest common denominator, is going to be 18. So we'll write both of these as something over 18. We need to convert 1/6 to something over 18. So multiply this by 3 over 3. Essentially, we're multiplying by 1, so that gives me 3/18. And then multiply this by, say, 2 over 2. 2 times 9 is our 18. 2 times 2 is 4. Now that we have a common denominator, we can add the numerators. So 7 over 18. We're actually going to start out a little bit simpler than that. We're going to work with things that already have a common denominator, and then we're going to kind of build up from there. So problem number 20 is our first one. Y plus 2 over 10z plus y plus 4 over 10z. Now the nice thing here is that both of these already have a common denominator, so we can add their numerators. So it's going to be y plus 2 plus y plus 4 over 10z. Adding these together, we get 2y plus 6 over 10z. And it'd be nice if we were all done here, but we're not. There's a little bit more we can do. One thing you're going to have to avoid is a temptation to cancel out the common factors. You can't cancel the 2 out of the 6 and the 10, or the 2 out of the 10 and the 2. Rather, what we have to do is we have to factor these things. So it's the old factor first kind of thing at this point that we need to do. In the numerator, I can take out a 2. That leaves behind y plus 3. In the denominator, everything's already factored. But now that I've factored this, now that I have this times this over this times this, now I can do my cancellation. 2 goes into 2 once, and into 10 5 times. Overall, I'm left with y plus 3 over 5z. Make sure you look for that extra cancellation as you do these types of problems. Chances are it'll be there, and I want you to do that. Let's try a different one. Problem number 22. Kind of same problem in spirit. That is, we have something with common denominators. 1 over h squared minus 4h plus 5 plus h over h squared minus 4h plus 5. And the nice thing is that they've both got common denominators. So we can add these things together over that common denominator. So that's 1 plus h. Let me rewrite that as h plus 1, kind of putting it in descending order. But also let's notice that the denominator will factor. This is the nice case of factoring trinomials. So we need two things that, actually, you know what? It doesn't factor, does it? Unless I copied it. You know what? I copied it wrong. This should be a minus. So let's make that a minus all the way. Now we can factor this. We need two things that multiply to -5 and add to -4. Well, there's not much that multiplies to 5, so 5 and 1. The larger of these have to have this sign, so minus and a plus. Kind of like the last one, we get some nice cancellation. Make sure that when you divide out the h plus 1 term, you leave a 1 in the numerator. So 1 over h minus 5. Okay, let's keep going. Problem number 34. 5x plus 8 over 3x plus 15 minus 3x minus 2 over 3x plus 15. We're going to do two like this. I'm going to ask that you pause the video and try the next one before I finish it up. The tricky thing about this one is that when you're subtracting, this negative sign has to change both the terms here. So a lot of times when I'm working these things, I'll add this extra set of parentheses for myself. So what happens? Well, we've got common denominators, so let's subtract the numerators. 5x plus 8 minus 3x minus 2 over 3x plus 15. This negative has to distribute itself to both terms. If it didn't, this problem wouldn't work out as nice. So 5x plus 8 minus 3x plus 2. When we combine like terms in the numerator, 5x minus 3x is 2x. 8 plus 2 is 10. And boy, it does look tempting to just cancel everything out here, but we can't. If you did, you'd get it marked wrong. So what do we have to do? Well, we've got to factor each of these because you can't cancel into either of these parentheses. In both cases, we're going to factor out the GCF. In the numerator, that's a 2. In the denominator, that's a 3. If I factor out the 3, I'm going to leave behind x plus 5. If I factor out 2, I'm going to leave behind x plus 5 again. The nice thing is that now that I have it all factored, I can cancel that out and I'm left with 2/3. If you failed to distribute that negative to both of these terms, if I changed the sign on this but not on this one, I would have had a minus 2 here. I would have had 2x plus 6. I wouldn't have gotten this big cancellation. So I'd kind of be out of luck on that one. You really lose a lot of the credit on working this problem if you miss this cancellation. So be careful with distributing that negative. Let's try another one kind of like that. It'll be problem number 36. (8a squared over 2a plus 5 minus 4a squared plus 25 over 2a plus 5. So again, like the last one, we've got common denominators already, and you have to be careful in distributing this term here to the numerator. So I'd suggest you pause the video, try doing this yourself a little bit. Realize that the numerator is going to have to factor before you're going to get any cancellation with the denominator. So go ahead and pause the video. Okay, so how did it go for you? Well, let's find out. Like our previous ones, we're going to put parentheses around that term in the numerator. I'm going to have 8a squared minus 4a minus 25 This should be minus 4a squared minus 25 over 2a plus 5. These terms are like terms, so that can cancel. 4a squared minus 25 over 2a plus 5. Did you recognize this factorization? This is the difference of two squares. So it's going to be 2a plus 5 and 2a minus 5. The 2a plus 5 cancels, and we're left with 2a minus 5. I can't emphasize enough that you have to be careful when you're doing these types of subtractions to distribute that negative. If this was a 4a squared plus 25 because we forgot to distribute that negative, then that'd be prime. You couldn't factor it any further, so you'd kind of be out of luck there. Okay, so what's next? Well, a couple things. You're going to have to start working with things that don't have the same denominator. So that's going to mean two more steps: finding the LCD and converting to the LCD. And we'll do that in the next video.